School.
My name is Kosa, say 8 years old, primary 2, also from YUMIN Primary School.
This lesson is Calculus, Chapter 5, Indefinite Integral. Do you still remember those methods that we have used for these indefinite integrals?
Yes. There are 7 basic formulae: partial fraction, and integral by parts, and
Let's start from partial fraction.
okay.
Okay, after partial fraction is integral by parts, right?
Yes.
Then next is the substitution,
Correct.
right? And remember, inside this substitution, we have many ways of substitution, okay? For example, one of the ways can be,
One of the ways could be algebraic substitution, trigonometric substitution, substitution.
okay, inside this trigonometric substitution, we can have,
We could have
can we, like for example, x equals sine theta or cosine theta?
yes. And now we're focusing on substitution on the second question.
Like this, secant theta or cosecant theta.
Yes.
Tangent theta or cotangent theta.
Yes.
Tangent half theta.
Yeah.
Well, let me just tell you that it is actually very hard, okay?
Yeah.
And there can be actually many others, right?
Yes.
Right? And all these together, it can be the, call it the miscellaneous.
We will call it the miscellaneous.
Substitution.
Yes.
Okay? So we have these, okay? Okay, so we have these. Just take a quick look at this.
Yes.
And then can you erase it?
We can.
Okay, just a reminder that right now we're focusing on these substitutions.
Substitution on the second question.
Okay, so can we erase it?
Yep. And we were going to solve the first and second. I will solve the second question, second part, and you'll solve the rest. So the first part we actually didn't use substitution.
For this first part is that we show that the differentiation of inverse sine x is equal to 1 over square root 1 plus x squared.
Yes.
Okay, we actually have two methods, right?
Yup.
One is by this definition, which I will use.
Correct.
So let me start with this. And remember that differentiation and integration, there are the inverse operation, differentiation and integration. Okay?
Yes.
Okay, so remember in the past, we find that these two, they are equal, we just assume that these are equal, right?
Yeah.
We can actually call this an assumption, a hypothesis, right?
Mm-hmm.
Okay, so in this case, we find both, okay?
Yeah.
So first we have this dy dx, and here can be the limit. Limit delta x approaches to 0, then delta y over delta x.
Yes.
Then this will be fx plus
Delta x. Wait. It's x, not delta x.
like this, right?
Yes.
Okay, so next for this, it will become here will become inverse sine, right?
Yes.
Okay, so just to tell you what we'll use, first we'll have, you still remember the sarcocosa?
Yes, it was a sarcocosa.
So for this sine, alpha minus beta will be the,
So it will be sine alpha cosine beta.
minus, yes, then alpha minus beta. Because for this inverse sine, it's actually finding an angle. And another thing that we'll use is a special limit, right?
Yes.
Where's your limit if it's a special limit?
Okay.
Like this, is it right?
Yeah.
So it will be like this, right?
Yes.
You'll realize that here we have sine inverse sine, so that we can cancel.
write it more like a straight line.
Like
Continue.
this. Okay.
Continue. Just write your words more properly.
Okay, so at this part, this inverse sign, we have all of these, right?
Yep.
But now the problem is this part.
Yes.
Okay?
Yes.
So we can have for example, y equals inverse sine x, okay?
Yes.
So sine y is x, am I right?
Correct.
So this angle will be y. Here's x and here's 1. So it will be like this, right? Okay, so next, here inverse sine. So right now at this part, this inverse sine x, which is actually the y, so we're finding cosine y,
Yes.
which is this adjacent over hypo. Then after that, for this cosine and this inverse sine, we can put this x in front. Then the cosine, we can think that this is something like this, y, right? We'll just set this one at delta x, this one at delta x, and this one will become, from x squared becomes x plus delta x. And remember, it's this whole thing squared.
Yeah.
Like this. Am I right?
Yes.
Okay, so can we numerator, denominator times this?
Yeah.
Okay, so for this one we times we'll put it on both the numerator and denominator.
Yeah.
Like this, right?
Yep.
So what did you realize over here? Okay, focus. Don't get distracted. So for this part, what did you realize?
It is the special limit.
Yes. These two parts, right?
Yes. Then
So it will become a
it will become a 1.
yes.
Then later we'll do rationalization.
So for this rationalization, what should it be like? Which part change into a plus? Hello? Which part change into a plus?
Thus.
Yes. I right?
Yes.
So for this part, these 2 times, right?
Yeah.
So at this part, we can use the a minus b, a plus b, right?
Yeah.
Which is a squared minus b squared.
Yeah.
Okay, so right now at this part here, when you solve this, when you put this in, right? So at x, you have this x times the square root 1 minus x squared. Then here is actually the same, so we can just write it as like this, right? Is this correct?
Yeah.
So we can put this part outside. Okay, like this, correct? So right now at this part, like this, is it right?
Yeah.
So right now at this part, these two we can cancel, right?
Yes.
Then this we can expand, can we?
We can.
Focus. So like this, these two will cancel, right?
Yeah.
Then each one will still have this delta x, right? Right?
Yes, then we can simplify. After they become a determinable form, then we can sub in and simplify again.
Yes. So when we sub this in, we'll just be left with 2x.
Write it below. Okay.
Like this, right?
And write shown.
this. Is it right?
Yes.
Okay, come here. Okay, so you just take a quick look at all of these, okay?
Yes.
Remember, this is by the definition. We have another one.
But it's not definition.
Yes, and you can use it. There's actually a faster way, right? Okay, so can I erase this?
Yes.
Okay, so you'll continue with the next method, which will have the composite function
Yes.
and the chain rule. So your first let that be y. Are you missing something? Just right over here. So right now you can both sides differentiate with respect to x. Okay, so then you have the chain rule because then you need. Okay, first is for the sine, right? So sine becomes the cosine, and for that inverse sine, inverse. So for this inverse sine, you just leave it there. Okay, so that is 1. So for this, you can move this down here.
Wait, first.
D, first is this thing. Yeah. Yeah, so you divide it and then you draw the triangle. Okay, so you go according to this. Okay, so here what you have is the theta, that is the inverse sine x, right?
Yes.
So theta is inverse sine x, so sine theta is x.
Correct.
And sine is oppo over hypo, right? X can be x over 1, right? Using the Pythagoras theorem, we can find the adjacent, right?
Yeah.
So is that how you find it? Because that here is actually cosine, this is theta, right?
Yeah.
Okay, so here, still missing something? Okay, so it is proven, okay?
Yes.
So
But we
this-
haven't finished. We still have the second question, right?
the second part, right? Okay, so can we erase this part?
Mm. This time we'll use the substitution, okay?
Yep. Okay, so next for this, we'll need to show that this integral dx over square root 1 minus x squared is equal to inverse sine x plus c. And we'll use the substitution.
Yes.
How many ways of substitution do we have?
We
For
have
this,
trigonal substitution.
I'm asking for this one, right?
Yes.
Correct, it is trigonal substitution. But which one? We have sine, cosine, we have tangent, cotangent, we have secant, cosecant.
Sine
Yes.
or cosine.
So which one do you want me to show?
Sine.
Okay, so you said you want me to show the sine, right?
S.
Okay, so we can let this y be sine x, right?
Yep.
So when we let y be sine x, here we have
Yep.
Did you realize I wrote the opposite?
Oh, yep.
It should be like this, right? If not, when you sum it, it's the inverse sine. So for this, dx will be, so sine is,
Sine will be cosine.
like this. Am I right?
Correct.
Okay, x, what is the range? What's the range?
1 to -1. So we usually say -1 to 1.
Okay, for the angle, we can use y, we can use theta, right?
Yes.
Which one would you prefer? It means which one would you like to use?
Usually I would like to use theta.
Okay, because it stands for angle, right? Well, this is also okay. So for this, the range will be like this, from -½ pi to ½ pi, right?
Yes.
Okay, right now at this part, can we stop?
We can.
So for this 1 minus sine square, it will be a cosine square, right?
Yeah.
So it will be like this, then these two cancel. Like this, right?
Correct.
Well, you dare write it out. Well, here the identity sine square x plus cosine square x equals 1. This is, okay, so you write it like that. Then after that for this, because we want it in terms of this x, right?
Yeah.
Can it be like this? We have this inverse sine because we sum back, right?
Correct.
Okay, so this is to show you as one example, okay?
Yes.
The next. Okay. Okay, and this is all?
0.
Okay. Good. So you put it like that. It's okay? Well, for this, you actually use this identity, right?
Yes.
It's this way. Still theta. Here is already a theta. Okay then. Yes. Okay, so for this you'll use another identity.
Like this. Is that accuracy one?
Okay, yes. So you just write it like this. Oh, it's okay. For this inverse cosine, you just move this to the other side, right?
Yes.
Which will have a negative. So negative, negative, positive, right?
Correct.
Okay, so here is what you get, right? Am I right?
Correct.
So for this, okay, after for this substitution, we'll have an overall, like summarize these, and we'll have those questions, right?
Yes.
And these questions are to test whether we really understand these. After those, we can move on to the definite integral, okay?
Yes.
Okay, well for this substitution, remember we have different types, algebraic, logarithmic, well, and also these trigonometry, right? And many, many more.
Yes.
Okay, so far are you clear for this?
Yes, and what you want to say?
If you like our videos, don't forget to subscribe to our channel.
See you in the next lesson.
Okay. Thank you for your watching.